Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 123 and 124. We were discussing assignment number 10, the problem based on alternative standard state. Last day we actually solved this first part of problem number. Okay, what is that problem? Problem number 3, perhaps 3. Problem 3, first part. First part we have solved. The second part means B. Part A is solved. Part B we will take up today. I have not given the problem yet, written the problem yet. So I will first write the problem and then I'll solve this problem. Means this part of the problem 3. So this is our job today. What I have made actually here, I tell you what. Yes, very good here. Acha. This actually I have given you the relation between 3 standard state. I have saved this relation here. Previously we kept here, we wrote here the Hennian line equation in terms of 3 activities. Okay, so activities and mole fraction. Last these 3 were there. I have removed this because they are not necessary anymore. So today actually I have given this will be often used. So relation between the 3 standard states, namely Raoultian standard state, Hennian standard state mole fraction, and Hennian standard state weight percent. For example, here this is the between Raoultian standard state and Hennian standard state mole fraction. This I will show you this diagram. Actually, you don't see perhaps well, but this will see what is the difference. If I can tell you what is this. This is the free energy of this state, this standard state, which we call HMF, that is Hennian standard state mole fraction, and R Raoultian standard state. This one, these two. The difference between the free energy of this and this minus this. What is the result? RT ln gamma B0, that we know. I have saved this because often we have to refer to this. So it is better it is saved here so that we can easily find this and use it. Similarly, this is between Hennian standard state weight percent and Raoultian standard state. What is the Hennian standard state weight percent? This point, remember, this is this 1 weight percent. 1 weight percent on the Henry's law line. This one, 1 weight percent. What is the name of this? Symbol name is what? H weight percent. What is the name of the Raoultian standard state? R. What is the name of the Hennian standard state mole fraction? HMF. These symbols we used previously also. HMF. This is H weight percent. I have written full. This is Hennian standard state weight percent. But the point is the name of the point. This point, particular 1 weight percent point, is H weight percent, and this point HMF. HMF, Hennian MF, mole fraction, Hennian weight percent means 1 weight percent, and MM means 1 mole fraction. And this is Raoultian standard state, the physically pure standard state. This is okay, very good. This is this figure we will refer to this. These are the relationships, activity between activity relationship. See, for example, activity, Raoultian activity and Hennian activity mole fraction. Similarly, Raoultian activity and Hennian activity weight percent. So such a relationship. This we heard, this we actually said, and this we have actually here. And this is what this I told you. This is we may actually use this. We may use this often. So these are also saved. This will help. So that's why I have said the state under study. Okay, this is standard state. Okay, this is RTLN AI. Okay, so this is, and what is another one? It is standard state 1 and standard state 2. 1 can be Raoultian, 2 can be Hennian. 1 can be Raoultian solid, 2 can be Raoultian liquid also. That is actually 1 and 2. This is the relationship from which we actually alternatively you can write this, because This will be direct actually. This I will transpose this to the other side. I discussed this point last time. So this you know, this you are used to, this here you used to, this they are XP and OP% conversion in binary system, and this is the relation of activity coefficient, Henrian activity coefficient, mole fraction or weight percent, and which is equals to gamma B by gamma B0. These are already discussed and saved for solving problems or just in case explanation and understanding. Okay, these are it. So the problem currently, as I told you, problem is already last day. I tell you what, there was no confusion. Everything was correct. That I tell you, calculate gamma V0 with respect to liquid volume. Oh, I'm very sorry. Gamma V for vanadium. Gamma V0 with respect to liquid vanadium as standard state. As standard state. As standard state, and gamma V0 with respect to solid vanadium as standard state. As standard state. Okay. So this is actually at 1600 degree centigrade using the following two data on the change of the standard state, this and this. This is actually, these are change of standard state. This is vanadium liquid means this is Raoultian standard state but pure liquid, and okay, and this is also another standard state, 1 weight% liquid, 1 weight% in liquid iron Henrian standard state. For example, this 1 weight% standard state. So 3 standard state here. But incidentally, the Raoultian standard state has been considered two different ways. One is pure liquid, another is pure solid. Pure. So vanadium solid and vanadium liquid. Incidentally, this is phase transformation also. So this delta G0 is given, all these things given. So we have nicely solved both of them. First we have solved what is required, liquid volume. This is in short this. Gamma V0 with respect to liquid volume. Oh, sorry, I am very sorry. Gamma V0 with respect to liquid liquid vanadium as standard state. This is correct. Okay. So for example, here, so this is a B iron vanadium binary. So a B here is vanadium. So vanadium is a pure vanadium liquid. Pure vanadium liquid. So this means actually. I tell you what, you should first understand, appreciate this, that why it is about this first problem still. B I have not taken up yet. I'll soon consider. About this I tell you, gamma V0 also actually is actually referring to liquid, pure liquid vanadium, and gamma V0 solid is referring to pure solid vanadium is pure solid vanadium as standard state. So these are, normally we say activity always requires a standard state. But remember, gamma activity coefficient follows activity. Activity coefficient is activity coefficient times mole fraction. So if you have activities of a species reference to a certain standard state, activity coefficient will also be reference to that particular standard state. So here you see the source here source here is liquid vanadium standard state. How it is? Just I will give you 1 minute here. Where is the data? Follow this. Suppose here, what is this? You have written somewhere. Last day actually I have removed all these things, or maybe somewhere here perhaps. Here, this part actually. Delta G0, you can see this. Is 1873. But anyway, these are all removed actually. 37 point, etc. 30, this one, yes, still there. Still there. You will understand now. This is another mental block. Another serious mental block, that it is 37.57 T. 37.57 T is 1873 Kelvin, 1600 degrees centigrade. The steel making temperature typically. So this is the delta G0 we have calculated. This is Joule. And then we actually use the relationship delta G0 is R3 ln Aj. Delta G0 is this delta G0. What is this? Between this and this. Between this and this. Delta G0 is what? RT ln gamma RT ln gamma V0 liquid, atomic weight of A. Oh, A means iron. Atomic weight of iron plus 99 atomic weight of B. Where you will get this? Today I have saved you for you. See, this is the difference between this one. This is Hennian standard state. See here. Hennian standard state 100% minus Raoultian liquid. Or see simply Raoultian. Hennian standard state 8% minus Raoultian standard state. What is the answer? RT ln RT ln gamma B0 means gamma V0. Liquid, I will explain this, and atomic weight of A over atomic weight of A over atomic weight of A plus 99 atomic weight of B. If you don't follow here, you see here atomic weight of A plus 99 atomic weight of B. This actually come down directly for the other change of standard state. Last one. So, but this term is denominator is here atomic weight of A plus 99 atomic weight of B. So this is the relation. This is directly I have used this RT ln gamma V0 liquid extraction. This you clearly see. This is solved last day. And why it is? Question is why sir gamma V0 liquid sir? Easiest way to get the answer is this is liquid. So this is gamma V0 liquid. If this is solid, as we have solved in the later this case, next case, solid. How it has been converted actually conversion as in the form we just added this to or subtracted last day I showed you. This should be taken to this side and this to the other side, and then you add this, then volumes V solid will be on the left hand side and V 8% on the right hand side, and this V liquid cancel. Take this on this side means this will be plus and this will be minus. Sign will be changed for delta G0. As you know, this done last day, and what was the result? This was the finally result. This was the result for this gamma B0 solid. So what is when you write gamma B0 liquid and gamma liquid when you are considering this B liquid to B 108%, and when gamma B0 solid when it is B solid to B 108%. This is actually this is the answer, but better answer, even more in-depth answer is this. Follow this conceptual, more conceptual will be this. If follow this. What is this? So you just try to understand this. This delta G0 I have written here. Delta follow this. Delta G0 I wrote means G0 of this minus G0 of that. What I said, when this minus this minus this I have written here. Follow 8% minus RSS Raoultian. Then what is the answer? What is the meaning? It is how do you get this value? How do you get this value? You say if it is GI0, fit into this. Suppose this is GI0, the Raoultian standard. So to consider this minus GI0 minus GB0 Raoultian standard state. So this plays the role of GI0. Then the other side is GI. Maybe this is another standard state, does not matter. With respect to this is simply that any GI bar. Anything other than this will be then GI bar. If it is GI0, then this will be GI bar. If this is GI0, then this will be GI bar. This depends. So since you want to fit here, so GI bar minus GI0 is what is answer? I told you repeatedly, RT ln AI activity. This activity of what? I remember I told you what? Activity of this state. Activity of this state. Activity of this state, or activity of this state relative to this state. Just I showed this with arrow. activity of this state, and this arrow is for with respect to this standard state. Activity must have a standard state. Today you learn that activity coefficient likewise have a standard reference standard state, because activity coefficient comes from activity. Activity is activity coefficient times mole fraction. So, so for this is the so why gamma we are used to this activity with respect to this standard state and of this activity of this state respect to this state. This actually I discussed in problem 1 and problem 2. Okay, great extent, and so there should not be any confusion. But you want to see here, so activity of B at this state with respect to this state, and at this state what is the activity? What is the activity? This is 108%. Is activity falls on the Henry's law line. So gamma B0 XB, and if you do this XB calculation for 108%, this emerges. So this gamma B, this activity, this is actually what it is representing, the whole thing. It is gamma B0 XB. Activity AB, a tail end activity with respect to Raoult's means AB. What is the AB? What is the equation of this line? Gamma B0 XB is equal to this. I draw this once more. Gamma B0 XB, and what is the XB? Since this is the state under study, HB, H8%, this is here. This is of this state, activity with respect to of this, with respect to this state, activity of this state with respect to Raoult's standard state, and activity symbol is Raoult's standard state A. So AB value here, it is under the line gamma B0 XB, and XB corresponding to 108%. If you do this and you did this, so this will be actually the answer. So you now understand this is actually activity with respect to what? With respect to this one. Of this with respect to this. This is what Raoult's standard state. And what it is here in this problem? Liquid. See, this is this Henry and 8%, this one. And Raoult's standard state, this one. What is this? With respect to Raoult's standard state, but this is liquid. We have to be specific here whether it is liquid Raoult's standard state or solid Raoult's standard state, because there are two questions with respect to this gamma B0 liquid and gamma B0 solid. So you have to careful, and you have given also that change in standard state of say phase transformation delta G0. So you can manipulate this one so that you can get B solid to V108%. Easily just manipulating this. Just as I told you, subtracting and write this. Okay, B solid this side, B liquid this side, and change the sign, and then add, you will get B solid. So in either case you have. So when it is liquid, you will say activity of this state. This is of this state. Okay, means this activity of this state is this here, right there. This is written actual. This is written actual here. Of this state relative to this state. Activity of this state relative to this state. Activity of this state relative to Raoult's standard state. Now, what is the Raoult's standard state here? Liquid Raoult's standard state. So, activity of this state with respect to liquid ion. So, this is actual gamma B0. If activity B with respect to liquid, I'm very sorry, activity with respect to liquid vanadium. I'm sorry, activity with respect to liquid vanadium. Okay, this is actually B. This is the Raoult's standard state. B is 1. Here. B means vanadium. So with respect to liquid vanadium as standard state, so this activity, and if with respect to liquid vanadium as standard state, so gamma B0 means gamma vanadium 0 will be with respect to liquid vanadium as standard state, and that is asked with respect to liquid vanadium as standard state, and short form, in short, gamma B0 liquid. It means gamma B0 with respect to liquid vanadium standard state. This you have to understand that activity. This is normally we don't consider. We at the most give activity with respect to this standard state of that standard state. That is also actually conceptual thing. Even you actually manage this, then normally we don't consider gamma activity coefficient. Activity coefficient will be treated in the same manner. If activity in same manner as activity means if activity has activity of B refers to a solid standard state, pure solid Raoult's standard state, gamma corresponding gamma B0 or gamma B will refer to the same standard state, namely pure solid Gaussian standard state. Like this. So, see, this is the meaning of this. So I said this. I had thought I will give you some comments. Like a lot of discussion. So this is conceptual. Conceptual. Why sometimes you write in bracket? I don't understand why I write in bracket. Sometimes you don't write to avoid confusion, to avoid being actually erroneous or incorrect. So don't write at all. But to be see this means gamma B0 with respect to liquid vanadium as standard state, and this is with respect to solid vanadium as standard state, as clearly written here. And you follow this. Remember always this GI bar. This follow repeatedly. I am saying GI bar can be which one? Follow this Henrian weight percent standard state. Free energy of this. The GI bar. This can be this, and GI0 can be Raoultian. In the previous one, first one, what is this? GI bar is what? GB Hennian standard state mole fraction. Free energy of this one. Since it is standard state, 0, superscript 0. And minus is what? Again, still Raoultian. In the third, what is GI bar and what is GI0? You may consider this. See, I tell you, you write. When you write this way, you will see the result is activity. Result activity activity of this state relative to this state. Remember, of this state relative to this, of this state relative to this, of this state relative to this, of this state relative to this. And when it is relative to Raoultian, actually life is easy because with means then activity AB symbol you use, and AB symbol means you have the diagram you are used to AB versus HB, so no problem. Yeah, in fact, nothing is problematic. No problem in any case if you understand. But what I want to say, it is more straightforward. AB is this, or then actually I repeat this diagram I am writing for you before I proceed to the part B. Okay, this diagram will be very helpful. So I want to this part, since I'm drawing here. I'm drawing. This place is the best place, but this is important often for understanding. For why understanding these relations, G0 of this minus G0 of this, G0 of this minus G0 of this. 3, 1 minus 2, 1 minus 3, 2 minus 3, etc. So I'm drawing this figure once more for clarity. This side, this will be saved. This will be saved. This is actually our famous. I think I will be able to explain. This is your, okay, you write here, you draw this. This is your so-called Raoultian line. Draw this, and this is your draw this, and this is your straight. Then you bend this. This is your so-called deviation from Raoult's law, but a part of which initial part is linear and follows Henry's law. And this is the extension of Henry's law. Maybe better. This is better drawn. Okay, good. This is the Henry's law extension. Henry's law up to which point? Up to this. On this deviation, Henry's law follows. And this is the extension. This is actually extension. The actual curve is this little up the small linear part, Henry's law. Then this changes into non-linear and reaches there. What is this? Now you will write this xb perhaps here, xb 0 to 1. This is your note this is your 1 weight percent B. It is on the Henry's law line. Okay, 1 weight percent B, say here. It can be here also. It can be here. It can be not on the card, but on the extrapolation. Maybe here. No problem. Same deal. Okay, 1 weight percent B, the standard state, and this is your Henrian standard state. What is the simple? This is the Raoultian standard state first. R, you write here Raoultian standard state. This is, tell me what? This is your H. Name is what? Point is point. Point is this point. Exactly this point. And this point. This state. Point means state. H. MF. I use this symbol. And this is still another. I cannot write here. I don't have space. So if you don't mind, I cannot take much space here. H weight percent. Like H MF mole fraction H weight percent. This point corresponding to 1 weight percent B. Okay. What else? The XB. When XB is, you know very well, when XB is 0, this is called pure A. XB is 1, this is called pure B. And this side is AB. The moment I write AB, you know, this is Raoult's activity. Moves from 0 to 1. Okay, 0 to 1. H weight percent name. Okay, this is you may write this equation of this line. Okay, do you like this? This was actually what I wrote. It is, what is the name? What is the equation? Activity B is gamma B0, Henry's law line. Henry's law line extrapolation though. But what is the equation? Same equation is AB is gamma B0 XP. This you know. And this is AB is XP, Raoult's law. Raoult's law is AB is XP. So this figure I will refer to. Now when I free energy of this standard state minus free energy of this standard state minus this standard state, or the reverse. Free energy of this standard state minus free energy of this standard state. Both are standard state. This is right? This Henryan. I'm sorry. This is Henryan standard state, right? What type? Mole fraction. And what is this standard state? 88%. This is this one. This point. This point is Henryan standard state. I'm sorry, I cannot have so much space actually. Henryan standard state. What is that? This is mole fraction. This is so 3 points. Play with these 3 points and clarify your knowledge. This standard state, this standard state, this standard state. Difference between this minus this. First one. Difference between this point means this is the Henryan standard state. The free energy of this standard state minus free energy of this standard state is what? Is what given in a second. And again, between these two, both are Henryan. Free energy of this standard state minus this standard state. Free energy of this Henryan mole fraction standard state. This is free energy of Henryan weight percent standard state. This minus this given here. Results are given here. Okay, remember. So these are all discussed previously, but I am repeating this so that you have no doubt. Today you will learn one thing, that not only activity refers to standard state, activity coefficient also refers to standard state. Sometimes this is very implied because when there is no question of confusion, but when there is a question of confusion like this problem I have removed because they are asking gamma V0 solid ones and gamma V0 liquid, means liquid vanadium Raoultian standard state of liquid as pure liquid vanadium, and Raoultian standard state of pure as pure solid vanadium. Pure solid vanadium, both are pure physical Raoultian, but one is solid, another is liquid. So Raoultian standard state can have 2 types, okay, or maybe more. You can consider 1 atmosphere gas as the standard state, but this is we are not under our discussion. So this you will follow. So first, but actually I have removed some data. So I have to save these answers before I take up. Sorry, before I take up, perhaps these answers I am saying part A answers. This will be used. Gamma V0 solid answer 0.141 answer yesterday, and A part A and 2 answers. Gamma V0 liquid is 0.119 answer. Save this. Save this A. Now take up the part B. But for part B, actually one data is required here from part A, but I have removed this. But anyway, you remove all these things now. These are last days. Now take up, actually I am in the continuation of the last days class B. Okay, I discussed so much time, I discussed so many things so much time. Okay, and so I am removing, since I have already drawn there, so I generate some space here. I hope actually, but this space actually I wanted to use it, but anyway I cannot help. If necessary, I will see. But this save. These are you save this. Save. You save. Okay, these are saved. Okay, very good. Solution here. This problem 3. Problem 3. 2 already. First part of 3 is already done. 3B, you let us write the problem. What is the problem? Now move fast. Now move little bit fast actually. If a liquid iron vanadium solution is equilibrated with equilibrated with pure solid vanadium oxide, pure solid vanadium oxide, VO, and a gas phase containing gas phase containing PO2. PO2 is 6.45 times 10 power minus 11 atmosphere. No problem. Calculate. You give fencing here. Okay, these are all saved. Okay, calculate. What will calculate? The activity of vanadium. Calculate C. Activity. ACTIVITY. Means don't attach any symbol without knowing the reference state. The symbol AB, I repeatedly say AB will be for Raoultian standard state, and HB mole fraction for Henrian mole fraction standard state. And again I repeat, it is actually not a Henrian mole fraction, it is 1 mole fraction. 1 mole fraction here. Hypothetical standard state. Extrapolation. It is theoretical extrapolation. It is actually mathematical extrapolation. And okay, so and H, that is HB, because this H, this is A, this is H mole fraction, and this is H weight percent symbol are assigned already. So since I don't know, I am writing right phrase ACTIVITY activity. This has meaning. When I say ACTIVITY has meaning that I don't know whether it is Raoultian, but it can be otherwise. Careful, and you will see now. Activity, calculate the activity of V is vanadium in the liquid solution. In the liquid solution at 1600 degrees centigrade, which is 1873 Kelvin. This is your question, second part. Given data is given is what? 2V solid plus O2 gas, 2VO solid, delta G0 is what you know? Delta G0 is minus 861 minus 861,500 plus 153 joule. Okay, this is the data given. And other data, reference I have already given from DR gas scale, I gave you last day. This is the second part, already I have given you. So solution part B. Okay, so you see, calculate the activity of vanadium in the liquid. Volume, I am very sorry, I have missed something. Calculate the activity of vanadium. Sorry, no. This is not so easy. This is not so easy. Data I am giving, this should have been given at the end because the question is not complete. Here, star, I am very sorry. This is the question starts. Activity of B, ACTI, BITY, activity of B with respect to what? Yes, this is mentioned now. Okay. Actually, after this, you will read this. A, with respect to solid vanadium as the standard state. Second, with respect to, you guess, liquid vanadium as the standard state. What else it can be? These both are Gaussian, but one is pure solid vanadium, pure liquid vanadium. What can we expect questions with respect to? Play with this. With respect to Henry-Ion mole fraction standard state. Henry-Ion mole fraction standard state. So what will write this? 1 mole fraction with respect to 1 mole fraction vanadium in liquid iron. Henry-Ion standard state. So called 1 mole fraction means exactly this with respect to this standard state. Any activity must be reference to a standard state. D, last guess, what remains? 1 weight percent. Weight percent vanadium in liquid iron, Henry-Ion standard state. So these four actually. Again, what is this state? You tell me. This. This is the standard state. With respect to this, find the activity of vanadium. With respect to solid and liquid, etc. Start. So you since this data is given, data should be here. Data is here. Data place data here. Okay. So solution. Write this out. 2B. Have a sketch. Sketch will be helpful. What you have? Tell me what you have. This is your sketch. What you have? Tell me. Okay. You have here. Iron, vanadium, liquid, melt, solution. Then what else is sitting here? B2O5, BO, pure solid BO is also present. And who else? Oxygen gas. What is the pressure? PO2 is given to you 6.45 times 10 to the power minus 11 atmosphere. Atmosphere. What to find? Find the activity of B. It is not pure, it is with iron, impure. So activity of B means vanadium in this melt, in this liquid solution. So this is the question. So I will show you how to write. You write this, the pertinent equilibrium solution, you should write this. 2B solid plus oxygen gas is 2VO solid. Quickly. Delta G0 is already there. You have to write this. Minus 861,500 plus 150 T joule. This is joule. Okay. And then you start. So delta G0, what temperature we are talking about? 1873. You substitute here. Minus 861,500 plus 150 times 1873. All you have solved problem 7. So many problems, so many millions problems you have solved. So this is no problem. Delta G0 81873 is minus 580 minus 580 555 joule. Okay. Then what you will get from this? Delta G0 is recall. Delta G0 is minus R3 ln K, or what it is, minus 580 555 is minus R is what? In Joule, 8.314, you know. What is the temperature? 1873 ln K. Get out K ln K, as if we get this out, K will be K 1873, should be at last the temperature, function of temperature, and this temperature is 1873 Kelvin. So K 1873 is 1.55 times 10 to the power 16. You calculate this, you get this. 1.55 into 10 to the power 16 is what? Equilibrium constant expression, as you know. This is equilibrium. This is equilibrium state. Equilibrium state. It is written somewhere in the problem. See here. Is in equilibrium, equilibrated with equilibrium constant. So what is this? You write this, as you know, AVO square. Solid. This is solid. AVO solid. But you understand, this is pure solid, geosolid. AVO square, then AV square, AV square times PO2. This refers to equilibrium. As I always write. What is this value? This is sitting here pure. So these are in equilibrium. The meaning of this at 1873 K. So temperature I have not mentioned. 1873 Kelvin. And what pressure? This is the pressure. Total single gas species. So this, and what is the PO2? You know this. What is this value? 6.48 times 10 to the power minus 11. So what comes out from this? Or activity of V, okay, activity of vanadium, okay, is what comes, what is the activity of vanadium in this liquid, okay. Okay, very good. This is actually, this will come at, by the way, by the way, activity of, see, this is a liquid phase. This is a liquid phase. What is the activity of vanadium with respect to what? This is very interesting question. With respect to what? Solid vanadium as standard state. Why, sir? Why, sir? This is liquid. And that's why it's so much important to understand this. This is because you have considered here. Since you consider this, it may be, okay. This is actually to be solid. Actually, you see, vanadium melting point is much greater than 1873 Kelvin. It is about 2000 Kelvin. So it should be in solid state. But since it is with alloyed with iron, which has a lower melting point of 1539 degrees centigrade, so it is in the liquid state. So anyway, so you consider this. You consider this data given because question is on that. Again, another thing you follow. Now onwards, you follow this. This delta G0 means, you know what? G0 of the state minus, as you know, minus G0 of the reactants together. This is this these standards, the standard in the standard state to be also this free energy of this in the standard state, this in the standard state, and this in the standard state, and you have to subtract product minus reactant. This is the delta G. So this in bracket, this is not now onwards, particularly when you solve this type of problem, when there is a confusion of this alternative standard state, you should be certain that these are the reference standard state. This is the standard state. Which standard state here? This standard state. EP12 liquid, that has a different standard state. In fact, much greater than this. So result would be different. So in bracket is the standard state that is referred here, that is given here. Which standard state? This is the difference of standard state, product and reactant. But which standard state? This is, after all, this is liquid, iron vanadium liquid. No, no, maybe you find activity of vanadium with respect to, interesting question, interesting phrase, activity of vanadium in the liquid solution, iron vanadium liquid solution with respect to solid vanadium as a standard state. Do it. And next time, of course, do activity of vanadium in this solution again with respect to liquid vanadium as the standard state. Let's play with this. No problem. Absolutely. But then what you consider? Here you consider liquid. How to consider? Just transfer. Subtract, add B solid, B vanadium solid to vanadium liquid. Just manipulation. That I will show you. Here also. So what comes out from this? That's why solid. Since it is solid. Now onwards you consider, oh, these are the standard energy chain. Which standard state? Ask everyone, what is your standard state? It says solid means Raoultian standard state. Physical, pure solid, Raoultian standard state. Ask it, what is your standard state? Yes, pure solid, Raoultian. Ask it, if gas means Raoultian. For gas, 1 atmosphere gas, 1 atmosphere oxygen. Their free energies, when you consider, this is the result as a function of temperature, 2 terms. Okay, so very good. So you understand activity. This answer, so you will calculate this. Answer is coming out as you write nicely. Answer is coming out as 10 to the power 10 powered minus 3, and you just say answer. Answer A. You write A here. A means second part A. Or part B is this part, first part A. What is the unit? No, activity has never unit. Ratio of two fugacities means ratio of two vapor pressures. No unit. Very good. You know this. Just at times I will check whether you are following this. Second part you take this. This is solution A. Say A, maybe A, and the answer A. B quickly. What you are interested in. Similarly, only you need to get to tell me to be liquid. Since the question is with respect to liquid volume, right? Liquid. 2 liquid plus O2 gas is 2 VO solid. This has not changed. This part has not changed. Okay. Vanadium it is there. This system is equilibrium in each case, but your answer will differ depending upon the standard state. This is physically true. Physically actually consistent with each part. This is physically this constant, physically same. This equilibrium remains. This equilibrium applicable to each case. There cannot be any change. This physical situation unchanged. Question 1. What is the activity of B? ACTI, with respect to vanadium solid, with respect to vanadium liquid, with respect to 1 mole fraction Henrian standard state, with respect to 1 weight percent Henrian standard state. First to what I said, with respect to pure solid vanadium is Raoultian. Pure liquid vanadium, again Raoultian. Both are Raoultian, but they don't have same free energy because it cannot be. You know, solid and liquid have the same free energy at the melting point only. Below melting point, solid have lower free energy than the liquid. That's why solid is a stable state below melting point, and the opposite above the melting point. Liquid has a lower free energy. So you write delta G0. How will you get this? This data is not given. This is given. But another thing is given. I have removed that data. What is that data? Tell me. So this is question mark. Find this. How will you find this? So this is how will you find. You apply this. Okay, I'm taking time for your benefit only. You first write this. Oxygen gas, write this. Is 2 VO solid, write this. Delta G0 copy. Minus 861,500 plus 150 joule And what you do here, V liquid, 2V liquid goes to 2V solid, delta G0. This phase transformation data or say change of standard state data. Anything you say. This is one type of standard state, another type of standard state. Both are Raoulsian pure liquid, Raoulsian pure solid. So this data, last day actually, I actually, I removed this, but you remember this, I am writing for you, V liquid to V solid. Last day it was what? It was what I am writing for you. Here, last day, delta G0 is what? Minus 17,600, plus 8.04 T. Actually, I removed this problem. First part, this data was given. For which one? No, sorry, for this. For this. But you need two V solid to cancel this 2V solid and to bring in 2V liquid, 2V. So what it will be? 2 times, sir. 2 times this. 2 times this and joule. You multiply by 2, right? Nicely. 2 times. Okay. And then what you do? Add this plus. Then obviously solid cancel, which are desired thing. So remains 2V liquid plus O2 gas goes to 2VO solid. Understand? And delta G0, you do this. See, add this and you get this data. Delta G0 will be, as I tell you, minus 896. Nicely right, minus 896,700. Happy? Minus 896,700 plus 106.002 plus 166.008, sorry, 08 T joule. You can do yourself, you check this. How much time left? 1 hour 8 minutes. 1 hour 8 minutes, 7, 8. Thank you. So this, okay. So that, see, like this now, this is like this. Only instead of solid, liquid. Why it has changed? Because solid vanadium, pure solid vanadium has different free energy from pure liquid vanadium. When under what condition they have the same free energy? Only exceptional situation, that is the melting point of vanadium. Melting point vanadium, if you want to know what this is, 2193 Kelvin. Add that. Below less than this, vanadium solid will have, less than means below this. Solid vanadium has lower free energy than the liquid, means different. Above, liquid have lower free energy than solid, again different. So hey, since this has changed, what has changed? Again, standard state. This standard state, same. Delta G0 for what? G0 of this. Ask which standard state? It is written in the bracket. Previously, we thought that these are written to show the physical state of vanadium. No, physical state will be given in the problem description. Now follow. Previously there was no class because what we see here was there. Physical description as well as the bracket here, the standard state reference. This should mean the standard state energy because delta G0 is what? G0 of this as the standard state product minus G0 of this and G0 of this as reactant together. They are different. So standard state. Now see, so these two are unchanged. This has changed. And must change because they have different free energies. Very good. So this. So remember what I said. Emphasize this point that bracket refers to with liquid vanadium as standard state here. Here we have considered, and here oxygen as Raoulsian standard state clearly 1 atmosphere oxygen, and this is also Raoulsian vanadium oxide solid as the state. And they are different. Then you get this value. So these values, this refers to these all three. Now, what is the standard state? Ask here in the bracket. This is more important when you come to the Henry standard state, which you will have considered in this problem itself. These two, you'll see. So quickly I can solve this problem. Delta G0, 1873. How much it is? Take it from me. Delta 83 is minus 58563 minus, I hope minus 58536 5856 5856 32.16. This is again is minus RT ln K, RT ln K, Hodge temperature K 1873. I should not proceed here. I will show you here only. This is 8.314 as you know. This is 1873 as you know, and then K it is. If you, can I give a star mark here in case it will be out of focus? So question is this problem is shown by the diagram. So I am removing this part. This part. So make some room. Make some room. Or calculate the activity of vanadium in this part is calculate the activity. Oh, I'm sorry. 861500. 500 T. Sorry, I'm very sorry. Okay, anyway, it will do. Okay, this calculate. Question was calculate the activity ACTIVITI of vanadium in liquid iron. Okay, write this. Vanadium in the liquid solution. In the liquid solution actually, or in the liquid solution. Solution means iron vanadium solution. Iron vanadium solution at 1600 centigrade. At 1600 degree centigrade. I'm sorry, I repeated this. At again with respect to A, B, C, D. A is over, B is going to B. I'm sorry, you don't have to write. You give a star mark here. So what you get? Star. You calculate this. K 1873 is what? Tell me. K 1873. No, you cannot. K 1873 is 2.15. 2.15 times 10 to the power 16. Happy? Goes to tell me what is the equilibrium constant expression. See which one? This one you are working with. This one, or this one. This means this. This one. Activity, product by reactor activity. Write this nicely. And suitable activity. Which activity here? Solid means Gaussian symbol A. BO square. BO square. And what is the product reactant? A. Liquid. Liquid means still Gaussian. Gaussian but liquid actually. It's right. AB liquid if you want to write liquid plus in times PO2. You know PO2 is given to you. Value is 6.48 times 10 to the power minus 1, 11. I'm very sorry, 11. ABO is what? As before, this is solid, pure ACC, physically pure BO. It doesn't enter into solution. Oxides don't enter with the metal phase. Normally, okay. So or say to the almost fully, okay, slag metal, Anyway, so this is nothing. So his activity is pure one. So activity of, see this way, activity of pure solid vanadium with respect to here, with respect to pure, the delta G refers to pure solid vanadium. What is answer? 1. Now you understand this one. So what is coming out? Or write this activity of B liquid. If you do this, answer will turn out to be 8.5 times 10 to the power minus 4, and you of course write answer B. Answer A, answer is answer A, answer B. 2 down, C, D. That will take up. Before this, the last another complexity. I'm just okay on purpose entering into to clarify your knowledge. I ask you, suppose this is activity of vanadium solid you first calculated, you got this answer 10 to the power minus 3. What is your expectation about activity of B liquid? My question is this, will it be greater than this, less than this, or equal to this? Your answer will be this, sir. Activity. See, you now, last day I showed you actually, remember, okay? See, activity of the free energy, follow this part. This is very interesting. These free energy absolute, no reference. GI bar is free energy of this vanadium. Listen, this is unchangeable. A given situation. Who is changeable? You standard state. One time it is solid vanadium, another time it is liquid vanadium. Pure solid standard state, pure solid vanadium, pure liquid vanadium. Both are Gaussian though, admittedly, pure solid vanadium. So you see, I told you last day, if this same, here it is same. But you are measuring with respect to some two different references. So two different values, then activity will be accordingly different. Now greater or less, tell me, which is greater? Say solid, first one, solid free energy greater or liquid free energy, solid vanadium free energy of solid vanadium, this part. Free energy of solid vanadium greater or free energy of liquid vanadium greater at this temperature. I already told you, note, melting point of vanadium, this is not given in the problem, but I help you in this discussion. Melting point is 1920 degrees centigrade. Is what? 2193 Kelvin. Just in case. Sometimes which has greater free energy? Temperature is 1873 Kelvin, means 1600 degrees centigrade, which is below 1920 degrees centigrade, means solid is a stable state at this temperature, means solid, a liquid, okay? Solid is a stable state, means solid has lower free energy than the liquid. Liquid has greater free energy, that's why it is solid will be stable, because but iron vanadium liquid is present because presence of iron. Iron melting point is smaller. 1539, and you are discussing 1600 degrees centigrade. You know, liquid iron, blast furnace iron, and steel making steel, hot metal and liquid steel. You know very well. They are molten. So, very good. Now tell me which is greater. Of course, at this temperature, solid has lower free energy. If this is solid lower, means minus is lower. The result will be greater here. Activity with respect to solid will be greater than with respect to liquid. Let us check. With respect to solid will be greater. Solid is what? Just now I calculated what? Liquid. And solid is what? 10 to the power minus 3. Greater than 8.5 times 10 to the minus 4. It's greater than this. So you can actually, this is actually one thing, this is understanding. Shall I write here somewhere? 10 to the minus 3 is greater than a comment. This comment actually, comment. Is it possible? Comment. A small comment that solid has lower energies. This reference lower means result is greater. This is same. Decreases, increases. So what is this? If that's right, comment. This you understand. PO2 is good. I can do this. Don't worry. PO2 comment answer 10, which is it is greater 10 to the minus 3. Activity of the solid with respect to solid is 10 to the minus 3 greater than activity of B with respect to liquid standard state. With respect to activity of B in this iron vanadium liquid solution with respect to 2. I'm just play with this standard state. So what is greater than? What is that value? A moment ago, 8.5 times 10 to the minus 4. The reason is the GI0 is etc. GI0 etc. Because GI0 of solid is less than GI0 of liquid. So this has explained this part. Now remaining C and D. So okay. Not much difficult, but I don't think this will be required anymore. This will, but this figure maintain this. This is a system. System is described here. Equilibrium everything. Equilibrated system. Keep this. C. C is what? With respect to one mole fraction vanadium as a standard state. That's why I draw this figure. Now, which standard state? This time again activity of B in this. I hope this does not. This is important. This gives you the system description, physical situation, your problem, your project, your study. This figure, small figure. Please. Here, what is this? What I wrote here? Equilibrium state. Question is with respect to this, of which activity ACTI VITI of vanadium with respect vanadium in this iron vanadium liquid solution at 1600 degree centigrade. But that's understood. Of vanadium in liquid iron vanadium solution with respect to. Activity means always with respect to this one. Where is that? Which is that? State means standard state point. A point is a state. And another coming next time before, and I am telling you one weight percent this with respect to this measure. This point is name is H weight percent. The point name H, not H weight percent, because there are two H weight percent, but it is H point. This point name this. This is actually HSS weight percent standard state. This point refers to the Henrian standard state. One is mole fraction standard. This is a C. This is a D. C. So what is this? How you get this? Tell me. What is the relation between the activities? What you have got? Activity of in liquid iron. So the answers actually you see answers are here 10 to the minus 3 active solid. Okay. So with respect to liquid iron, so activity of B, and what is the relation? I'm first writing myself. This is the relation between these two activities. Since I know one activity already, so I can take this is the question. What is this value? This is the question. This is asking. Gamma B0 liquid. Do you know first part you calculated gamma B0 liquid. I have removed all these things, but I remember the answer gamma B0 liquid. Okay, so this after I said this is to be found out. Question mark. So activity V gamma B0 liquid. First part already found. Gamma B0 liquid. Please tell me what value gamma B0 is 0.119. Today I did discuss 0.119 already found. Part A. This is part B. I am discussing part A. Already. So what is the HB? What is this value? Activity of B liquid. Tell me. With respect to liquid vanadium as standard state value 8.5 times 10 to the minus 4. Now it is very easy. Only thing unknown is what? HB mole fraction. Activity again. What is this? Activity of vanadium in this iron vanadium solution with respect to this mole fraction. Is what answer? What answer, sir? 7.2 times 10 to the minus 3. Answer. Answer C. Good, very good, very good, very good. 0.119. Very good. Last one. Quickly. D. Oh, by the way, I'm very sorry. How I wrote this relation? How I wrote this relation? We know this is a relation between two different of two of activity of B in terms of two different standard state with respect to two different standard state. This is one standard state, another standard of B. B means vanadium here. Of vanadium with respect to two different standard. What is the relation? See here, see here. Yeah, here. Equation number 3. Please see. See, that's why I said this. This is AB is gamma B0 HBMF. What is the relation between the three activities? One is Gaussian. This is Henrian. This is relation Henrian mole fraction. AB I've written B here gamma B0 HBMF. So that's why I said this also. You remember this. You can very easily prove 3 step derivation. This one. So this is one answer. Last part to tell me what is this with respect to one weight percent means. Again I tell you with respect to this again same question with respect to this standard state. Okay. This point, name of the point is H weight percent. What is this point? Perfectly, precisely 1 weight percent B on the Henry's law line. State point D. What is the relation? What is the relation? Tell me. Do you know? You must know this. Gamma B0 liquid times atomic weight of. I am writing A first of all by atomic weight of plus 9. If it is wrong, I will correct it. Yeah? HB weight percent. What is this? What is this? These are known. These are no use. Already done. Huh? Times H B weight percent. First check that it is correct. AB, so next one. AB liquid. Gamma B0 is I mentioned here actually which standard state liquid vanadium as the standard state this time. Gamma B0, very good. This is see atomic weight of A by atomic weight of A plus 99 atomic weight of B. This should be not A. This is actually iron. And B is what? Vanadium. This one, second one, 11 question. So this you have this activity relationship between Gaussian and Henrian weight percent. This is the relation. So again you write substitute quickly. What is this value? Or again same thing. 8.5 times 10 to the minus 4. Happy. Gamma B0 is what? 0.119. Happy. It is 56. 56 plus 50, 99 times 51. Vanadium atomic weight. HB weight percent. The question. That you will find out. This is your job. Let me check actually if I have done. Or it's okay, everything okay. It's okay. So we are going to finish. Or HB weight percent. What is that? With respect to activity of vanadium, with respect to 1 weight percent vanadium in liquid iron, Henrian standard state. The H is what? How much it is? Is what you calculate this out, what you will get? 0.66 answer. So thank you very much. With this we have finished problem 3, problem 4, 5, 6, 3 more problem. Let me remove this. This slowly. This is all done. Problem 3 all over. Rest should be kept intact. Problem 4, right this, it is odd. It is odd here, odd. Problem 4 quickly. What is problem 4? Let us first of all write this. And iron, titanium, liquid solution containing titanium containing titanium at H 1 weight% in liquid iron. Henrian activity, okay, is 1. Is given you is 1 is what? In equilibrium with is in equilibrium or is in equilibrium with pure solid TiO2 and an H2O H2 better use it. You understood this is or this still just juggling. And H2 gas mixture in which in which pH2O over pH2 is 5.56 times times 10 to the power minus 3 at 1600 degrees centigrade. You always know this is 1873 Kelvin. Calculate gamma Ti0 with respect to liquid iron. I have written here with respect to liquid iron, or simply gamma Ti0 liquid L, liquid iron, fully expanded at 1600 degrees centigrade. Data, lot of data is given, and maybe right side I write the data. Ti solid, maybe here, good. Ti solid plus O2 gas is TiO2 solid. Delta G0 is what? Underneath I am writing delta G0 is minus 91000 plus 173 T joule. Happy 1. Titanium solid goes to titanium liquid. Delta G0 is what? Minus 18,800 plus 18,800 minus 9.7 T joule. Last is 2H2 gas plus oxygen gas goes to 2H2O gas, delta G0 is what? Minus 492 triple zero 000. Triple zero. Sorry, triple zero. Okay, no, not enough. Not enough. Plus entropy 109.60. 60 joule. Joule. These three data. I'll solve this problem. Let us see. You have to find. Oh, again sketch. Always sketch. Always sketch. What you have here, here. Iron, titanium, liquid. So liquid solution. Then what is still? What is another species is TiO2 solid. Pure TiO2 solid. Pure. Pure means you know what is that? The activity with respect to pure TiO2 is 1. Okay, pure. Okay. And what else? TiO2 solid. And you have a H2O, H2 gas. H2 gas. What is this value is? pH2 given is what? pH2 by pH2 is given in the problem 5.56 times 10 to the power minus 3. And what is this temperature is what? 1873 Kelvin. This is the system. This is the problem. This is actually here. Question is what? What is the question? You have to find gamma Ti0 with respect to find gamma Ti0 liquid means with respect to now I made a mistake somewhere. With respect to liquid titanium. Gamma Ti0 is here. Gamma B0 with respect to liquid titanium. What is here with respect to gamma Ti0 with respect to of which one with respect to activity with respect to this. This is what? This is B, Rahul Sinha. B means B pure XB1 and pure B pure B means B is what? Titanium with respect to pure titanium liquid. Iron is this side. Iron is this side. A is this side. B small concentration gradually increasing to pure liquid B. This is the diagram, you know. This is XB goes to 0 to 1. And this one is pure B. So I made a mistake here with respect to liquid titanium. Liquid iron, I'm by mistake. This is present in the with iron. Present with the iron. Alloy. Iron titanium alloy. There's no problem. There's no problem. With respect to liquid titanium. Okay. This is your question with respect to liquid titanium. I hope this will be. So you start the problem. This is your desired titanium. Pertinent equilibrium, right? Solution. Also, I have already started. This sketch is itself a solution. Sketch is itself a solution or part of the solution. The pertinent equilibrium is right nicely. See, say about this equilibrium. So what you write? I think titanium liquid plus H2O gas is 2H2O goes to TiO2 solid plus 2H2 gas No problem. No problem. Absolutely very good. Ti liquid, TH2 gas. These are the solid. This is solid. Okay. Is delta G0? How will you find this? Find this. I will not show this part. So just manipulate these three. For example, Ti liquid. So what you will do first? You just transpose this. Take to the left and this to the right. Take right hand side to the left hand side, right. So that when you add titanium solid will cancel. Ti liquid will remain. So do this, and here what you will do? You also transpose this because H2 should be on the left hand side. So transpose this and this to the other side. Remember, anytime you transpose or just you change the sides, delta G0 will be opposite sign. So when you titanium liquid to titanium solid, what is the delta G0? Is minus 18,800 plus this. Similarly, this one. And this is already titanium on the left hand side, titanium on the liquid, this liquid here. So liquid, when liquid comes to the left hand side, this is matching. So this is actually after this, so addition of this delta G0 suitably written is I am giving the answer actually here. Delta G0 I am giving. So this is very easy task. So I will not waste time. Minus 436. You check this. I give you this 436. These type of things you have done in assignment 7. So lot of practice already. 800 plus 73.1 T joule. Happy? 73.1 T joule or delta G0 what is the temperature you know very well? 1873. You substitute this. I don't want to do this. Substitute here. Minus 299,884. You can write joule always. Equilibrium constant K 1873. You know delta G0 is minus RT ln K. Or right here. Right, continue is minus RT ln K. K also the same temperature. K is a function of some 8.314 and T is what? 1873, or you get K 1873 is what? Tell me K 1873 is actually 2.31 times 10 to the power 8. Right, nicely right. Or K 1873 is 2.31 times 10 to the power 8. What is this? What is the expression for this, right? Follow this expression one by one. See, in this case, you know all these delta G refers to the standard states. What is the standard state? If I ask you, what will be your answer? What will you answer? I said, no problem, sir. This is actually standard states are given here. Physical situation there. Physical situation there. Here. Don't think that this is in the liquid state or not this, okay? Sometimes I may write titanium solid, but it is in the liquid in the last problem. In the last problem found, I am writing solid, vanadium, but it is in the liquid. So what this means now onwards, make sure this is the standard state reference. And that's why delta G0 you are getting. G0 of this state, G0 of this minus G0, minus G0. These are the standard state. They are free energies, certain free energies. And get the difference. All stuff have free energies. In the standard state, for example, what is this? Sir, you know what is this? Hydrogen gas. 1 atmospheric pressure is the free energy. Standard species, standard state, and 2 times its free energy, 2 times its free energy. This is free energy of titanium solid pure minus free energy of titanium pure liquid, standard state. Liquid means Raoultian standard state. And this is again gas means they all are Raoultian actually, yeah. Solid, liquid or gas. Thank you very much. So very good. So you have to know other symbol, Write this one with activity of TiO2. This is activity of gas means partial pressure. pH2 square. And what you have? Activity of titanium liquid. You know, very good. pH2 square. Okay. This is how much? Since this is present, physically 1. Okay. So what you have? 1 by ATI liquid. Activity of titanium. Why liquid, sir? Because it is liquid here. Activity of titanium with respect to liquid standard state. Because this is the reference. Why this came from this? This is reference state. the derivation gi bar minus gi zero. So of this, that's why it is Ti liquid. Okay, very good, very good. What it is? This is pH2 by pH2 squared. Not bad. Then what you are getting? Or activity of titanium liquid. First you find out is what? Tell me. 1 by 2.31 times 10 to the power 8 times pH2 by pH2 the whole square. What is this value? 5.56. 5 point pH2 over pH2 squared. So given this 5.56 times 10 to the power minus 3 squared. Happy? 10 to the power minus 3 squared. Okay. Very good. It gives you 1.4 times 10 to the power minus 4. Happy? But this is not asked. Incidentally, this is not asked. What is asked? Gamma Ti0. With respect to liquid titanium. Gamma Ti0. What is here got? Activity with respect to liquid titanium. ঠিক আছে liquid titanium. Okay, very good, very good, very good. So how to get this? How to connect this activity and this? What is the relationship? One thing is given. Have you noted? This is given. Hennian activity with respect to Hennian 1 weight % standard state activity is 1. So connect this activity and this activity. Gaussian, this Gaussian, this. So what is the relation? But we have, we know. Tell me what is the relation? Gaussian, you are doing number of times. It is gamma Ti0. You have must write. I'm writing gamma Ti0. Then like this H titanium weight % times, I'll show you here. It is somewhere, and I'm trying to actually do myself. Titanium, then atomic weight of A, atomic weight of iron by atomic weight of iron plus 99 atomic weight of vanadium. Check these two standard state, oh yeah, standard states relation. This here B is titanium, so it is gamma B0, gamma Ti0 liquid, because this is liquid with the two liquid. Titanium is the standard state as here, since source is here. So and that is asked also, that is asked. So this is HB here, and this part atomic weight of A means iron, B is the solute actually. See B A is the solvent. So atomic weight of iron plus 99 atomic weight of vanadium. Of course, this is at the standard state B. We have considered XB is 1. Of course, that is then when it is XB is 1, then actually A is 0. Okay, and this when XB is predominant, then that becomes solvent and A becomes solute. Okay, no problem. But anyway, but it's okay. It's okay. So now substitute this. What is this value? Already 1.4 times 10 to the minus 4 gamma Ti0 to be found. What is this value? Oh, it is better I write here. What is this value? Question give you 1 weight % in liquid iron is short weight %. Short 1 weight % in liquid iron. This is actually this. Hennian standard state activity of B, activity of titanium at 1 weight % liquid iron means this one. Weight % B means where? 1 weight % of B in AB solution. Where it is 1 weight %. It is AB solution always. It is pure A, pure B, otherwise solution. 1 weight % B. That is a mole fraction in the solution, AB solution. So HT was, this is one given to you, and these are the 56, and atomic weight of vanadium is how much? 51. Is it vanadium? It's titanium. Sorry. Atomic weight of titanium, I'm very sorry. Titanium atomic weight is what? 48. 48. So if you do this, you get, or gamma titanium 0, 0. Liquid is how much? Liquid is how much? You try yourself and okay, you get this same answer as I do. Okay, is what answer? 0.012. 0.012 answer. Problem 4 over. Problem 4 over. Okay. So next take up problem 5. Problem 5. Since problem 5, remove all about this problem. Okay. So let me remove from the top. Okay. You keep this okay clear. No confusion, please. Very important. Weight percent. And this point is name H weight percent state and there standard state. Problem 5. Quickly move on. When an iron phosphorus solution, iron phosphorus. Oh, this is this previous problem. Please write this previous problem. Problem 4. Note. I will write first. Problem 4. Problem 5 and problem 6 that I will discuss. Today reference. Dr. Gaskell. Second edition. Page number I give 4. Problem 4. Oh, problem 3. Problem 3 already I gave you. This is page 599. Page 519. Next one 5. Page 519. Both are 519. And last one is 5. All page 519. Yes, again, very good. Reference. I acknowledge Professor Gaskell that this problem, but these are exercise problem. When iron phosphorus liquid solution is equilibrated at 1900 Kelvin with solid CaO and solid 3CaO E2O5 and a gas phase containing PO2 is 10 to the power 10 powered minus 10 atmosphere PO2. The activity of phosphorus, the activity of phosphorus in the iron with respect to the 1 weight percent in liquid iron or simply 1 weight percent, but it is in the liquid 1 weight percent. This system is iron phosphorus liquid binary. Okay, Henry standard state obviously 1 weight percent Henry standard state is 20. The activity is given Given that 1 by 1 delta G0 1900 is minus 5,64600 joule for which reaction? 3CaO for 3CaO solid plus P2O5 gas plus P2O5 gas. I'm removing this now. I'm removing this reference. I need some space. P2O5 gas goes to 3CaO, P2O5, P2O5 solid. The solid. Delta G0 is how much? Okay, right. It's the next one. And delta G0 is minus 122,200 minus 19.2 T joule for half P2 gas goes to phosphorus 1 weight%. 1 weight% in liquid iron. Henry Standard State HSS. Okay, this is given in the form of A plus BT. This is absolutely given. Okay, very good, very nice problem. And third is calculate. Now these two are given. Calculate. Anything else? I think these two data are given. Calculate delta G0 1900 for P2 gas for the reaction. P2 gas plus 5 by 2 O2 gas goes to P2O5 gas. Given this data. Solution. You see, a sketch. Solution requires a sketch. You have the sketch. You have the sketch this like this previously. What you have here? Tell me. Phosphorus gas, such a iron phosphorus. Liquid solution. Iron phosphorus binary. Okay. Impure. And what you have? As pure what you have in the present here? Is it containing this? Two solids are there. CaO solid. And another is 3CaO P2O5 solid. I just could not accommodate here. And oxygen gas you have, and oxygen gas. So liquid phase solid, 2 solid, 1 gas. What is the pressure of oxygen PO2 given to you? This is containing 10 to the power minus 10 atmosphere. Okay, very good. This is given temperature. What temperature? 1900 Kelvin. Right. To find this delta G 900. So you see what equilibrium you will consider here. Okay, 2p. You follow me. 2p 1 weight% in liquid iron plus 5 by 2 O2 gas. Follow me. Plus 5 by 2 O2 gas plus plus 3CaO solid. The pertinent equilibrium. The pertinent equilibrium is plus what? Plus tell me. Plus is rather what? 3 quickly 3CaO P2O5 solid. Now I wrote this, you see here from here. What are the possible reactions? See, in the reaction, one thing another point, mental block. Iron is there, so you're writing phosphorus only. Why not iron? Iron is where? In the reaction. Iron is here. Iron is playing its role here. Your interest is in this phosphorus, okay, this equilibrium. But phosphorus is present with iron. Iron plus oxygen, you can write separate. If iron oxide is formed, that is not given. If it is given, then you consider iron plus oxygen goes to pure. Iron is impure with phosphorus. No problem. But since I am interested in phosphorus, I write, but I give due importance to iron by saying that this is impure. Underscore is impure. You may not give, but it is written here. No, it is written here, don't do. Phosphorus is impure. Underscore. In steel making we give impure iron underscore. So phosphorus taken care of, oxygen taken care of, and CO taken care of, and forming this. So this reaction is pertinent. This should be the right one, and I have written this. Now, what happens? What is this? Since you have to need it to gas actually, so now you have an option here. This conversion. Acha. By the way, uh-huh. This you. Acha, find out delta G0. I'm sorry. K, equilibrium constant. Very interesting. Equilibrium constant you can find out fast. You don't know delta G0. Find equilibrium constant how? Tell me, write this. Write it. All are given here. Given to you. Everything is given to you. Say, follow this. Activity of, right? Tell me. 3CO means 3CO. You can write Ca3P2O8. Ca3P2O8 or 3CaO P25. Okay, very good. This is okay, very good indeed. 3CaO P25. Then what else? Product reactant. What shall I write? Tell me. Shall I write AP square? Shall I? No, it's a Hennian standard state. 1 weight % liquid iron. This is liquid iron means it is Hennian standard. It is written here in liquid iron. Let me check. Hennian standard state. It is understood. We write AP? No. It is Gaussian. HP square. HP in fact HP weight %. Right? No problem. Weight % type. Hennian, there are two types. Times, tell me what is this? This gas means PO2, Gaussian. The gas is also Gaussian. Activity is partial pressure. Activity is what? Activity is actually what is the standard state? 1 atmosphere. So PO2 by 1 is PO2. Okay. This you know why activity of gases is partial pressure, because its reference state is 1 atmosphere. So PO2 by reference 1. Use this, this is what? Activity of Ca. This is again solid Gaussian. CaO cubed. It's okay. What is this? This is pure. This is also pure solid. Gone with 1. This is also gone 1. This is given to you as what is the 10 to the minus 10 power 5 by 2. What is this? This is also given. What is the HP? Tell me. Yes. The activity of phosphorus in the iron with respect to 1 weight % liquid iron is 20. So all given. This helps you to find K. What is the value of K? You could do this. But shall I write? Tidy up, but I don't have to. I don't have to tidy up. It is 25 times 10 to the power 21. K. Now what is the delta G0? Which temperature it is K? Which temperature? The whole thing is 1900 Kelvin. K 1900. So delta G0 1900. How much it is quickly? Minus RT ln K 1900. What is this? K 1900 is how much? 25 times 10 to the power 21. T is 1. 1900. R is what? 8.314. gives you what value? Delta G0 1900. If you do this, it gives you minus 814681. Minus 814681 joule. Very good. Now align. You align. You so that you arrive at this. How will align? I tell you. You follow me. Okay. You follow me. You start with this. You start with this. 2p. So. See how I arrange this data so that I arrive at this equation, reaction, and which has unknown delta G0, but from the three known delta G0, I'll get this unknown. That is the idea. Three energy is a state property, as you know. You have done number of times. Do this quickly. Don't write this nicely. 2p. Write this quickly. 1 weight%. I am writing 1 weight% short. 2p. Understand? Just I am copying this. Copying this. 5/2 O2 gas plus 3AO. To keep your mind here so that the final reaction is this, means left hand side will be P2 gas, 5/2 O2 gas, and right hand side will be P2O5 gas. Let us see what we get. First you write, first one you write, as you see here, is 3CaO P2O5 solid. Happy? And you write delta G0 right here, delta G0 1900, data you write, data you should write. How much you got? Minus 814681 joule. Okay, 1. So next one, what you write? You just bring this. You have to get P2 gas, but it is P 1 weight%. This conversion is given somewhere. Yeah. Conversion is given. So you write so that P2 gas comes to the left hand side, because so write this and multiply by 2. So I am writing P2 gas. Follow me. This concentrate on this. Please concentrate on this. I am writing P2 gas goes to 2p, half P2, P2 2p, and this will be multiplied by 2. That I'll do. P2 gas goes to 2p, 1 weight%. See, you see here when I add, this will cancel, and P2 will be here left hand side, and should be left hand side in the final desired one. Plus goes to, what is the delta G0? Please tell me. P2 gas to what is the bit here? P2 gas to 2p 8%. It will be 2 times this. Okay. Delta G0 is 2 times. Delta 5, 10, 5, 10 minutes maybe. Delta G0 2 times is where? 2 times where? Oh, I'm distracted. 2 times here. Okay. So the same side. Okay. So 2 times is just 2 times minus 122,200 minus 19.2 T. T is what? How much T? T is 1900. Sorry. T is what? T is what? 1900. Bracket. This will be, let me write this. Have I done this? This value is what? Is minus 317. You can write this from me. Minus 19.2, 1900 is what? This value is minus 317,360 joule. 2. And third is what you have already here. What you have? Data. This one now use. See CaO P25 on the right hand side, and this is also right hand side, but you don't want, you bring it to the left hand side so they cancel on addition. Bring it to the left hand side. So you write this 3CaO P2O5 solid. This one I'm writing. Solid goes to 3CaO solid plus P2O5 gas. Plus P2O5 gas, where it is? Plus P2O5 gas. This one. What is the delta G0? Can anyone tell me? What is the delta G0? See the delta G0 given 900, right? 900. Each case, these all are 1900. All 1900. This is also 1900. What is this value? I have written this left hand side, that right hand, this left hand side, right hand side. this one to the right hand side and this one to the left hand side. So what will be this value? Plus 564600 joule. And now just safely add this 3. We add this, what you will get? Say cancel 3CO, 3CaO P2O5, 3CO P2O5 cancel, 2P108%, 2P108% cancel, 3CO right hand side, this is left hand side, cancel. What remains? That remains, this will be P2 gas. Take a look, what remains? P2 gas on the left hand side and 5/2 O2 gas on the left hand side, and right hand side what remains? Right hand side what remains? Right hand side what remains? P2O5. See, take a look. What right hand side P2O5 gas. Delta G0 1900 will be what? You will add this value, add these 3 value, and it will be what value for you? Minus 567441 joule is what values are? This last line I am writing. I'm writing here first. Minus, sorry, where it is? Minus 5, 6, 7, 4, 4, 1 joule. Answer. In case you don't see, I am writing here. Answer here. Problem 5 answer is what? Writing here. Just start this. Repeat. Write this. P2 gas 5/2 O2 gas goes to P2O5 gas. Delta G0 1900 is minus, to repeat, minus 567441 joule. What is the answer? Done. Problem 4. What is this problem? 5 done. Problem 6. So remove this immediately. Remove this. Apo, problem 6. 1 hour 58 minutes. I don't understand.
1 hour 15 minutes done.
Okay. This okay. I am just writing the problem. It is so I will be one step ahead. Okay. Let us apply this. Problem 6 probably I cannot solve today, but let me write the problem so that actually we will save time next class. Problem 6. This is the last problem. Last problem. Contained liquid iron contained in a